Alright, so does a trapezoid have 4 sides? Yes. What do you notice about your trapezoid that makes it special compared to other 4-sided shapes? Sides are equal? Yeah, none of the sides are equal. Not even opposite sides. Do we have any sides that are parallel? Yeah. Okay, that's the whole point of a trapezoid. A trapezoid is where there's exactly one pair of parallel sides. And that's the key. A parallelogram and a trapezoid have to be in different groups. There's no overlap because a parallelogram has to have 2 pairs of parallel sides, opposite sides. And a trapezoid is just one pair. There's only a top and a bottom or a side to side. It's not both happening at the same time. Okay, so in this in this diagram, which sides are parallel? The top and bottom. What do we call the top part? TQ is going to be parallel to SR. And we can show those with those little parallel arrows. And we call those sides that are parallel the base. Okay, so the base of the trapezoid are the sides that are parallel. So in our case, what is one of the bases? TQ or QT. Aw, I am a cutie, thanks. Or, what's the other base? SR. Okay, then we have our other sides. Our other sides, we have QR and ST or TS. We have special names for those ones. Again, they're not congruent, so I'm not going to mark them. I'm just highlighting them in that color so I can see them a little bit better. And those are called legs. And the legs are the sides that are not parallel. You might hear that word non-parallel. Non is the prefix for not. I just was like, that's a long word. Also, I just forgot that that word existed, honestly, until I saw it. Yeah, I don't know. It doesn't shorten it. Alright, so in this case, what are our legs? TS and QR. Or ST and RQ. You can put them in any way. Alright, we have one more word that we're going to put with this drawing. And that's base angles. And I'm going to do that in pencil because we're going to... Because there's just a couple pairs here. We can't do all the angles in one color. Okay, and base angles is a pair of angles that share a base. So for a base angle, what we're going to do is we're going to pick one of the bases, which is one of the sides that's parallel. So in our drawing, what's one of the bases we have? What? TQ. What are two angles have that as part of their, I'm sorry. Which pair of angles include TQ as part of the angle? Or what angles are in that TQ segment? Angle T. And that angle T is a base angle as long as it's paired with what's at the other end of the base. What? Q. Q. Oh my God. T and Q go together. Or what else can go together? Angle R and angle. Oh. How can you hear so good? I think I'm losing my hearing. Maybe. All right, I know I said that was our last thing, but we're going to write one more thing because I lied. We know that in a trapezoid, consecutive angles are supplementary. Nope. That's not right. Nope, nope, nope. Don't write that. I don't know how to phrase that. I didn't write it on my old notes either. Not consecutive. We'll come back to this. Cross that out for now. Or erase. I'm sorry. My bad. We'll come back to it. Alright, now we are going to take this handy dandy one. This one with no words on it, but it's a trapezoid. And we're going to glue that in right there. I can also call it leg angles, but leg angles isn't a word. It's not a term. But that's what I want to call it. Leg angles are supplementary. We'll come back to it. I'll figure it out, maybe. Alright, so this is a trapezoid, which, let's label it. Just A, B, C, D, or do you guys want to be more creative? A, B, C, D. Alright, which sides are the base? Good. A, B, and DC are bases. These are parallel. What are the legs? AD and BC. What we know about this trapezoid is special because AD is congruent to BC. Those are the same measure. They're not going in the same direction, but they're the same amount. So I put those little tick marks saying they're congruent. And we call this an isosceles trapezoid. Where else have you heard that word isosceles, or what other shapes have isosceles? Triangle. And an isosceles triangle, what was important about it that made it different than equilateral or scalene? How many sides were the same? Two. Two legs were the same. So we call them in triangles were legs. And what do we call these things? Legs. The legs are the same. So isosceles trapezoid is a special trapezoid with congruent legs. Maybe bullet point that if you want. Now, there's a couple things we know about isosceles trapezoids that are special because we have those congruent sides. They don't apply to all trapezoids, but specifically to isosceles trapezoids. What we know is that the base angles are congruent. So what's one pair of base angles we have in our trapezoid A, B, C, D? There's 4 angles. I want to know which 2 angles connect with a base, are touching because of a base.
On the drawing you see up, which color are we using for the bases? Which color are we using? The green. Okay. So you're going to look at the angles that connect on a green line.
So with DC, what angles are there on DC?
Yep.
D and C, and those are going to be congruent. Those are equal to each other in an isosceles triangle. I'm sorry, isosceles trapezoid. What other base angles do we have? A and B. Those aren't congruent to C and D, but they're congruent to each other. So we're going to use those 2 arcs to say that they're congruent to each other, but not to the bottom ones. All right, last thing we know about isosceles trapezoids are that the diagonals Okay, the diagonals are congruent. We don't have the diagonals drawn in on this one, but I think you guys have one that is, so let's just glue that in real quick. That's that QST. We're going to do a couple examples with this QRST. All right, so for this trapezoid, is it an isosceles trapezoid? Are the legs congruent to each other? Yep. If we want to label them, we can. So if you would like to use that same color coding, I'm going to do my base in the green. Alright, so for our first problem here, if QS equals 13 centimeters, what does RT equal? How do you know? Because it's congruent. Beautiful. If one diagonal is 13, it goes across, it connects the corner to a corner. That's the same as the other diagonal if it's an isosceles trapezoid, which we know is isosceles because those sides are congruent. Alright, number 2. If the measure of angle QRS is 115 degrees. I want to know what is the measure of angle RQT. So I'm going to look and see where is angle QRS. Really, QRS is what other angle if we were going to be a little bit lazier about it?
How else would we name that angle?
That would just be angle R, but because we have that diagonal there, we have to use 3 letters because there's lots of angles. So QRS, that's 115 degrees. It's asking me to find RQT. So RQT. So Q. Are those 2 angles congruent? Are they base angles together? There's a base that connects them? Not necessarily. They're connected by a leg. So this is not mathematically correct, so please don't go to Miss Lundy and tattle on me because sometimes Miss Lundy doesn't like it when I say things that aren't mathematical. There is no such thing as leg angles, but I'm going to call it leg angles because they share a leg. So leg angles that are next to each other and they share a leg, are supplementary. And what does supplementary mean again? Add up to 180. This is what I was trying to say earlier, but I messed it up. So how am I going to find the measure of angle Q if I know that R is 115 degrees? And what's 180 minus 115? 65? I think it's 65, right? So the measure of angle RQT is 65 degrees.
And we wouldn't even have to think of this consecutive. And what do we know about consecutive? They do, or if you put these together, what do they make? A line. Not a line here. So we're naming them right angles here, but that idea I think a lot of you already had without that name. You just weren't quite talking about it in the same way. When you look at it, you can see that they might add up to 180.
The big thing is that they're connecting between one base and the other base. They can't go this way. That's the goofy part. That's why I didn't say consecutive. All right. We have one more thing with trapezoids that we're going to try and get through before lunch, and then we have a really, really quick kite lesson right after lunch. Kites are simple, easy peasy. All right, last one, trapezoids. You need this one that has all the lines on it. All right, so get that glued in. Glue it in so you can stick up the notes. Keep up with notes. You can do it. All right, this one, we have this line. And where is VY located in the trapezoid? In the middle. So wouldn't it make sense for us to call it the mid segment? Because what does that prefix mid mean? The middle. And what is segment? A line. It's a middle line. Okay, and what's really cool about this is it's the line that connects the midpoints of each leg. So we know V is a midpoint, and we know the midpoint, and it's the line that connects the midpoints. Now this is a kind of a silly formula, but it's just a formula to know that they might ask you on a trapezoid. I think it's just all sorts of goofy. I don't know why. I don't know. I'm not going to go on that tangent. All right. What we know is that VY, the mid segment, equals, what we're going to do is we're going to take FE, the top number, we're going to add the bottom number, and then divide by 2. So it's an average. Say it again? Yeah, that's how you would find the mid-segment. I feel like that was just a question to show that you're listening. It's on my phone for 3 minutes. How can I make it look like I was paying attention? I'm just kidding. All right. So, for example, we're on example number 3 now. If I know that FE is 6, and CD is 14, how could I find how could I find VY? Good, we're going to do 6 plus 14, and then divide by 2. So what is 6 plus 14? 20? And 20 divided by 2, 10. So VY equals 10. We're going to do one more example like this. This one's a little bit different. I'm going to just write it next to it, though, because I didn't use a whole lot of space there. This is example number 4. All right. If FE equals 12 and VY equals 18, how can I find CD, the bottom? Can I add 18 and 12 together and just divide by 2? No. So we're going to have to think about this as an equation that we need to solve. So VY, I'm going to plug that in. VY is 18, right? So 18 equals, and there's a parenthesis here. Do we know FE? 12 plus, do we know CD? Nope, so I'm just going to write CD there. Keep that CD. Divided by 2. Now, if I want to get CD by itself, are we going to undo the 12 first or undo the dividing by 2? Normally we would undo adding first, but who is like the best friend of the CD? Is the 12 the best friend or the 2 of the CD? There you go. Thanks. So we have to get rid of the things on the outside of the parentheses first. So how do we undo a dividing by 2? Multiply by 2. So we'd have 36 equals, now there's nothing on the outside of the parentheses, so I can just write 12 plus CD.
So because we took everything else away, those parentheses don't have a job anymore. We don't need them anymore. So their job is to keep things together, and now there's nothing else there. So now we can separate them.
And some of you might be able to just do that mental math, 12 plus what is 36? Or you might think of it as solving an equation. What's the opposite of adding? Subtracting. So what does CD end up equaling? Alright, we are going to do the kites after lunch. Kites will take us about 3 or 4 minutes, so try and get back here as soon as you can after lunch. And then that's it. Have a good lunch.